Hello and welcome to today's SEI webcast. What's wrong with ROI for model-based analysis of cyber physical systems? My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our webcast today as interactive as possible, so submit questions in the YouTube chat area, and we will get to as many as we can. Our featured speakers today are Fred Schenker, Jerome Yuga, and Linda Parker Gates. Fred is a senior software systems engineer here at the SEI. Jerome is a senior researcher on our Assuring Cyber Physical Systems team. And Linda leads the Software Acquisition Pathways Initiative within our Software Solutions division. Now I'd like to turn it over to Linda Parker Gates. Linda, all yours.
Thank you very much, Shane. Hi, Fred. Hi, Jerome. It's great to see you both. So you presented a paper at this year's Naval Postgraduate School Acquisition Research Symposium back in May. And in the paper, you put forth the practical benefits of building early architectural models of embedded computing resources for cyber physical systems. So I want to hear about why you decided to write this paper. But first, can you talk about your perspectives that you bring from your individual backgrounds and why you chose to collaborate with each other on this?
Sure. So I work in the software acquisition pathways group within the software solutions division, and one of our customers is a Future Vertical Lift program, both of the programs, and they're trying to implement what's called an architecture-centric virtual integration, which is basically doing model-based approach for these helicopter platforms, and so my perspective is really trying to help the program get the right language on contract, motivate the contractors to do things the right way, and it's a different point of view than, for example, a practitioner would have. So maybe Jerome, you could speak a little bit about that.
Definitely. So I'm coming from the Assuring Cyber Physical System group here at the SEI. And within this group, I'm working in the MBE, model-based engineering team. In our group, our concentration obviously is on models. And we're interested in multiple facets of modeling techniques in general. First off, we need modeling languages to express design, to express intent. We need modeling verification methods so that we can extract information from models and turn this into specific analysis or analytical models that can provide some confidence that a model will meet some specific performance metrics or safety or security objectives. And ultimately, we need a modeling process that will orchestrate all those activities: design, requirements, architecting, validation, verification, implementation, all together. And this is on this process and objectives that we meet, Fred and I. Because ultimately, as a model practitioner, my goal is to make sure that I can deliver processes and methodologies so that models can be used to meet the objectives of a program. And it is very important that we do this as early as possible, because as we were, when I say we as the SEI, were working on various aspects of model-based techniques, what we have discovered is that many defects in system were detected very early, were detected very late in the process, but injected very early in the design process. What we can realize, obviously, is that the later they are detected, the more costly they will be to correct. And this is the reason why we wanted to develop a set of modeling techniques so that we can detect analytically, using mathematics foundations, defects in a system as early as possible. But of course, this is a scientific side of the question, and we have to push forward to transition those ideas into practice. And this is where people like Fred and Linda come into practice.
I think I'd like to add that basically the trend is that the cyber physical systems that we are building are becoming more and more complicated, and software and embedded computing are being employed more and more as part of the technical solution. And we believe this is only going to get worse as time goes on. And what the impact of that is that we're not able to predict what's going to happen if we change some aspect of the system. And the model is a very useful way to predict or to help the design process. Architectural models are, I think, primarily used for analysis, so that you can evaluate and improve the quality or the robustness of the design. And by using the architectural models earlier, you identify what we usually find later, which are these constraints, computing constraints or memory, which manifest themselves as system latencies or other aspects of the system that are undesirable, which then require us to redesign very late in the process. In that graphic that we had up a few minutes ago, it shows kind of the impact of the late discovery of those issues and constraints. However, when we talk to acquirers and contractors, we don't find that they're jumping off their seats to go and try to build these models and change the way they do business. And one of the reasons that we found as there's like a roadblock is that they believe that something like ROI is required to prove that this approach is better than the other way. And the fundamental thing that we've written in this paper is that we don't believe that this requirement for ROI is real. And we in the paper we explain why we don't think it's real, and we give you some alternate ways to think about it for this type of system development.
Thanks, Fred. So I think it's really nice to have these two perspectives in the paper, this sort of engineering perspective, as well as the more programmatic and policy focused view. Before we get into the ROI piece, I wanted to ask why you decided to focus on embedded computing resources specifically in this paper. So why that focus?
So I think in engineering, models are used in virtually every single engineering domain, mechanical, electrical, thermodynamic. I mean, you find them everywhere. Radio frequency. It's a fact that engineers use models to improve the quality of their design. But for some reason, we're not finding that when we design and develop embedded computing systems, that people are using models in the same way. On the other hand, we know, I mean, maybe not 100%, but we have a very good idea what the computing requirements are for the platform very early in the process. So it's not like we can't represent that in a model form, and then use the model to get an early look into how the system will behave. And what that provides is some confidence in the system. The early identification of constraints provide a mechanism, a way for the design team to manage the constraint and make trade-offs or look for new technologies early, way before you are in a under the gun situation to get the thing out the door, which is the way it normally is. And really, the models are the keys to enabling that.
Okay, thank you. I don't know if we still have Jerome, but Fred, I wanted to ask you more about sort of your vision then for the environment of the future, coupling architectural models with model-based analysis methods, as you describe in the paper. Can you talk a little bit about that?
Sure. So since we know the computing resource requirements early in lifecycle, we should be able to use the models to help us perform design trade-offs, analyzing the product requirements, and doing what you would call maybe functional analysis. This enters into the realm of systems engineering. And these processes are are done early in product lifecycle by systems engineers, and they're typically done without models. But the models could be used, and we think they should be used as a way to bridge the system engineering allocation and functionality and requirements analysis with some executable way of implementing that using a representation of the computing that will be available on the system. So I would really expect in the future that the systems engineering and requirements work would be closely coupled with people that are developing these models of embedded computing, evolving them, and make a natural bridge to the development of the software.
And there are plenty of domains in which this is the absolutely normal way to do work.
It is, right. I think in many cases, the analysis is done in very specific areas locally. Like we look at the deflection of a wing on an airplane or something like that, mechanical analysis or finite element analysis for that. In this case, we are talking about the whole platform, but it's certainly the principles apply across the board. Jerome is back, I think.
I am, yeah. Yeah, so I can bring a different perspective on this, especially on the connection with the embedded platform. And sorry, I just got a crush of mine at home, so fortunately I could reconnect with you. So as we are building very complex systems, so Fred at the very beginning mentioned cyber-physical systems, but also mentioned the future vertical lift system. Ideally, from the outside, when we will see it flying, it will be one consistent system. But we know from the inside that it will be actually a collection of system of systems. Some of them will collect data from all types of sensors. We can think about cameras, we can think about GPS, navigation utilities, etc., etc. Behind that, we have to allocate functions to those sensors because they will need to collect data and process it and provide feedback to the pilot so that he can make a decision on what to do next. And for all those reasons, we have to be very aware of all the issues in terms of latency, in terms of safety, if a sensor is not operating as expected, etc., etc. And the sooner we know about those potential issues, the easier it will be for a system engineer to take any correction on the architecture of the system to decide whether or not he will have to replicate some functions, whether he will have to move some function from one sensor to another, from one CPU to another. All of this is costly because we are dealing with a number of sensors, with a number of networks on board, with a number of processors on board, and all of that has an impact ultimately on the safety of the system, but also on its capability to deliver its mission. And so the sooner we integrate some notions of the embedded platform, the safer it will be from program perspective to take those events into account so that we know that we can deliver the system that is expected by the customer.
So we do have a question from someone in our audience, and it actually leads into the next thing I wanted to ask you about, which is the you mentioned in the paper that the rate of adoption for this kind of modeling has been slow, and that as a community we've been reluctant to embrace modeling of these kinds of computing resources. Can you talk about what you're seeing, and then walk us into the ROI problem?
I think the reason why, it's probably a multitude of different reasons. There's cultural, there's competency, there's all kinds of reasons why we have issues with adoption. It's not clear to me that there's a quick fix for that those sorts of problems. So, but I do think that there's a big, the ROI question is a major objection, and you can think about it easily because in the case of a model-based approach, we are actually building something that we never built before. If you look at the legacy way that we build systems without models, and now we're going to add a new artifact to the mix, there's going to be cost, and we're going to have to figure out how to change the process in order to make that work in our context. So it's natural to think that there will be cost that is different than more cost than we currently have. And really, that's sort of at the very front end of where the objections start. And people are worried about redundant effort, putting effort into a model for this purpose as compared to a model for that purpose. There's potential for not efficient use of the models, but that's sort of a case that misses the point of what we're trying to accomplish with the models. We are trying to make the process more effective so that we don't find all these problems at the end, which cost hundreds of times more to fix than when we find them earlier. So it's sort of and that's really a difficult part of explaining why it's difficult to show ROI. So, for example, in an ROI case, we typically require apples to apples. We have a need for seeing side by side why this way versus that way, and that's born out of like typical incremental process improvements. But when you completely change the way you do business, I mean, you're radically changing your approach. It's very difficult to get apples and apples.
So, and I think it's complicated by a few other things, like there's the virtual nature of things, right? So you're modeling something it's not like modeling a bridge or testing materials and things like that. And you also are in the position of having to account for things that don't happen, which is tricky, right? How do you measure the advantages that you gain by avoiding things? It's like we've talked about the diplomacy problem. How do you take credit for incidents that don't happen, right?
Yes. Well, I mean, taking a step back, the nature of DoD acquisitions are that they last for years. So trying to have two teams working on the same problem for years is just not practical. And if you try to limit the project scope, then it's really not representative. So there's sort of that's at the most basic level why it's a problem. And then the systems that we're building are challenging the technical limits. And we're doing, it's not like we're doing basket weaving. So we do have critical differences based on the competency of the actual employees that are working on the teams, which also makes things very difficult. The model-based approaches are not mature. I mean, when I say not mature, I think we have developed techniques, but within an organization, the first time they do a model-based project, they're going to learn from that, and they're going to change the way they do it the next time. And that's going to continue to evolve, which means that the process baseline is changing, also complicating an ROI. And then there aren't methods for quantifying the benefits. Some organizations will want to get products done quicker. Others will be looking at avoiding disasters in the integration lab. Others, so there's no official way to quantify benefit. And I do think that the thing that you were just talking about, which is that when we produce better design, we find less problems at the end. That makes it incredibly difficult to try to accrue the benefit, because we don't have an apples to apples meter, and say, well, they found this problem over here. We didn't find that one, so we get benefit for that. But really, that's just not the way it works.
And we're getting some concurrence, I think, in the comments from the viewers. One listener, one watcher says that his company thinks that models slow them down, right? So that's a different kind of cost, right? But if there's that perception that adding this new piece of work slows them down, then you get more resistance. So yeah, why is it all why is change so hard, and why is this all such a big deal? Can you kind of summarize that?
Well, I do think that that when you make a fundamental change like this, people are that have been used to doing things the old way are going to resist, and we're going to want to, people are going to want to be getting to the new way quicker, but people are very set in their ways. It's a cultural thing, and I would argue that at least they are learning that it's slower, but that doesn't mean that it's always going to be slower that way, and that they'll understand why it is slower and figure out how to improve it and make it more effective, so that maybe this part of it is slower, the front end maybe is slower, but when you look at it at the end, all the things that you did up front are really making the back end go much quicker. So, I think it's a learning thing.
Jerome, did you have something you wanted to add?
Yeah, a couple of comments actually, and there is a learning curve. Obviously, there is a need to go forward and understand what models can be used for. And when Fred mentioned this apple-to-apple comparison, basically when we discuss models, it's much more an apple versus apple pie comparison that we're doing, because when we build models, actually we build a chain of trust between requirement, architecture, implementation, analysis models, etc. And so basically what we are doing is baking together all type of models interconnected. So of course there is an because you're not just slicing an apple, you are just building the apple pie itself. But ultimately what we realize is that when we have to deliver a system, we don't just deliver a system, we deliver a system plus engineering artifacts, because the system will live for some of them 20, 30, 40 years. I see some comments from my friend Sushil Brilla on the chat, and he is from the nuclear domain. For those systems, for instance, a couple of weeks ago, Georgia started a new nuclear plant. We know that this nuclear plant will be in operation for 30 or 40 years. So having models, interconnecting engineering artifacts is critical so that we can improve it, we can monitor it, we can understand the way it has been built in the years to come. So this notion of cost is usually understood as an instantaneous cost today, not as the cost for the total life of the system. And really we have to think in terms of the apple pie, not just the apple that will contribute to the apple pie ultimately. And really this is one of the messages we want to pass in this discussion.
Thank you. There was a question also in the audience about, how you account for prevention. And the question is, can you do any of that sort of accounting based on historical data?
Yeah, so that's actually what we were going to talk about next, right? Alternate ways of looking at the benefits of ROI, or of a system. So one of the things that we recommend in the paper is that there are different ways to build justification for such an approach. Just because we can't build an apples to apples comparison doesn't mean we can do things like looking at different approaches. So for example, that we have enough experience. So for example, in other domains, we have shown the value of doing this model-based approach. Those domains, if you were to go to those organizations that have integrated the model-based approach into the way they do things, and you say, oh, we're going to take away your modeling tools because we think that's the right way to do things, they will not be happy. I mean, the fact is that we get used to doing things with the new tools, and we find that they're effective. And taking those things away will be a problem. And I think it's also important to recognize that we won't find everything using the models, that there will be things that will cost too much to model, and we're just going to have to make assumptions and wing it. But I think we'll get better. I mean, it's such a difficult thing to predict because the organizations that are implementing this have different capabilities and competencies. It's just difficult to anticipate how much benefit there's going to be. But I think we will find that there's more than enough, so that you can streamline your integration and test. And I think an easy way to do this is by using historical data. So I think we can look at prior projects where we have not used models. We can look at the defects that we found or the issues that we found in integration and test, and we can try to guess what we would have had to have done had we been using a model-based approach to have found that earlier in lifecycle. And that's not that in itself is a competency to be able to build the capability for analyzing the data like that within an organization. But I think you can easily then look at, well, how much did this thing cost in the lab, and how much would it have cost to build in the model? And we can start to make some predictions in that regard. And we can then also take those methods, that technique that we use, and actually build it into an operational root cause analysis kind of process where we look at defects or issues that we find in cycle and try to assess why we didn't find this earlier. Is it really injected in this phase, or is it something that has bleeded in from an earlier life cycle phase, and we should have found that using a model-based approach? And really, that builds up our competency and makes us better at doing using the models to make the system design easier.
So we have another question that is near and dear to me, so I'm going to indulge it here. The question is, isn't this like any other kind of change, and isn't there a science for affecting change? So yes, there's absolutely there is a whole domain around change management and technological change, and a lot of research around how that stuff can happen and how it sometimes does happen. Now, Fred, you had an example. I know we've talked about the microwave oven example in particular, but I wondered if you could share some of your insights around the things that push something over the edge, because in the paper you talk about different alternatives to ROI, and one of them is sort of like a leap of faith too, right? Just sort of believing that models are a good way to go. So my question is, how do you view change in general, and what do you think will kind of be the thing that pushes us over the edge in terms of using architectural models early in the cycle here?
The microwave example is a pretty good one. I mean, we did invent that and release that as a product that people could start buying in the late 60s. By 1983, 82, less than 10% of the households in the United States have microwaves in them, which is sort of embarrassing for the people that make the microwaves. I think they were expecting much broader adoption earlier, but for whatever reason, I think if you were alive, I was alive at that time, we all remember the issues that people would talk about, safety, the microwaves are going to prevent me from having children, whatever. I mean, there was lots of reasons why people decided they didn't want microwaves. And then oddly, and I'm not going to claim that this is an absolute fact, but in 1982, I believe, Orville Redenbacher invented microwave popcorn. And in 1986, the number of amount of money spent on microwave popcorn had increased from like $20 million to $500 million. And that kind of requires a lot of microwaves to pop all that popcorn. And by the end of the 1980s, 80% of the households in America had microwaves in them. And it's something like that, a triggering event. I mean, I think that organizations that adopt this approach earlier will learn the lessons earlier and will start to demonstrate the value of the process earlier, and they're going to be able to produce better products for our DoD warfighters quicker, and they should be. I mean, there should be tangible benefits to that make the ones that are late adopters, punish them. I mean, if we look at things, I think in the paper I also talked about the development of the rail in the 1800s. We had we had a big change at the end of the 18th century when we invented the steam engine and put that onto a transport, and all of the rails that existed started to break. So people had to develop new technologies for rail, and they had to be stronger. They had to be less brittle. They had to not break every time you ran your railroad car on there, and that was competitive. And companies went out of business because they didn't follow the science and build better rails. So, I mean, I do think it's going to, some things like that have to happen in order to make this really a snowball kind of effect.
And I appreciate that you kind of have a multi-pronged approach to thinking about this, because ROI will probably always speak to people, but thinking of alternatives and acknowledging that there may be sort of events that help out even more than logical arguments. I mean, we're all on Zoom probably because of COVID, right? I mean, things like this happen to push things along. We aren't in our studio all together, and that feels pretty comfortable, which I probably wouldn't be saying, 3 years ago, that probably wasn't the case. So, okay. We have one comment or one question from the audience. John Smith would like to know if you're familiar with orthogonal defect classification, and if this is different from that. Do you have a comment about that or an answer to that?
Do you want to take that?
Not at this stage. I'm not familiar with these techniques. My understanding is that it's more understanding what went wrong in the process. And with model-based, basically, it's something we want to avoid, either by construction, which will be as a GRAL, or at least by testing early hypotheses on the system by running all type of verification. So I'm not really exactly sure what was meant by Odyssey in this context.
Okay. I'll invite the questioner to send an email to the contacts at the end of the session if you want to dig into that further. Another question that I think is interesting is there a way to, let me see, I have to read this, to try to identify or categorize different types of software modeling and show the ROI for each against different parameters? So can the ROI problem be broken down, I guess, is what the question is, given that modeling can happen at different levels and at different times. Is there a way to break it down and show ROI in smaller chunks?
I think it's that's the natural way to start. And the problem is that you'll never get apples and apples. Mm-hmm. I mean, that's just when you break it into the smaller pieces, you'll find things that ought to be trends, but it's just a short-term view, and I think it's not invalid, but I don't think it's completely apples and apples. So I mean, I do think that's that's an opportunity, and I would recommend that that anybody that is starting down this path would not start at the whole system level to do this. I mean, I think you have to start in smaller chunks in order to build competency. You can't expect to do everything at once, unlike that movie from last year.
Yes, and if I may add, if we split in chunks, we may end up with a situation that we live in today, which is that enterprise architecture, it's UAF, it's a silo. System engineering, mostly requirement, block diagrams, system LV1, another silo. Cyber physical system, another silo, AADL. Control command system, SCADE, Simulink, a fourth silo. So we really have to think in terms of modeling processes, try to eventually model them using some business process modeling notation, for instance, so that we can understand what is information that we need to exchange between all of them, so that the ROI is not optimized with regards to a specific function within an enterprise architect versus system engineer versus system designers, but something that is an ROI that is optimized across every function within an enterprise. Because ultimately, this is what we want. We want to achieve higher performance at every single level so that ultimately the product is delivered faster with confidence. Not because Joe from the enterprise architecture department can reduce his budget significantly, but add a lot of overhead on other departments. So really we have to consider a holistic vision of this ROI question.
So before we get to recommendations, let me grab one more question, which is, does the size, maturity, or domain in which a company operates influence adoption of MBSE? And are there any domains that are ahead? Are you seeing differences domain-wise?
Well, I mean, I think MBSE is a very broad topic, and there are, if you look at I mean, even in the future vertical lift, there's a lot of MBSE that's used that's not related to embedded computing. Things, related to more traditional designs are being represented in MBSE. In their case, they're actually developing a model-based requirements model. I mean, for the acquisition, which is a completely different approach. But I think that broadly speaking, I mean, if you look at, like I said, virtually almost every design, we're using model-based tools for developing those designs, whether it's MBSE or CAD or whatever. I mean, it's just models are everywhere, and certainly there is a lot more experience in other domains than in this particular one.
Mm-hmm. Thanks. Okay, so I would like to ask you about your recommendations for both the acquisition community and for contractors or developers, people building systems. So maybe we can start with you, Jerome, to give us some recommendations for those building these systems.
Well, I would say for those building systems, I would say we have to understand what models are good for. I mean, there have been some comments on the fact that model may be slowing down people versus being something they can benefit from. So we really have to understand who are the stakeholders of models. And at some point, we also discuss adoption. Are you in a situation where you read models, where you produce models, where you review models? And definitely understanding your roles with regards to modeling effort is definitely important so that you can understand exactly how you may benefit from them. As mentioned by Fred, models are here to stay because of the benefits some people are seeing in them. And so that's perhaps the first aspect of it. The second aspect related to models is understand how they fit in the global enterprise you live in. And so modeling processes and the efficiency is definitely relevant as well. And so I would say those are my two key messages for model practitioners. Understand how building models may be something relevant, not just for your activity, but for your activity in connection with any other activities in the project you are working on. And I will leave the floor to Fred for the other side of the fence vision of the problem.
Okay, well, thank you. The for the acquirers, there's some steep learning that we need to accomplish. So a primary, I think, requirement for the acquisition community is one of fluency with the modeling methods, the tools. When you go to a design review and the contractor is explaining how they are doing something, it's very important that the acquirer is able to actually consume that information in real time and not get distracted or fall behind and then be playing catch up. I often equate this with someone that is early in their understanding of reading music, and they're being asked to turn pages for some pianist or something, and they can't figure out where they are in the on the sheet of music, and it becomes very difficult very quickly. So I think a competency question is at the root of the acquisition community's issues. I think also developing incentives, mechanisms, award fees that can be applied to successful adoption of modeling. I don't think you want to just reward companies that do modeling for the sake of modeling. I think we want there to be some kind of reward based on something that is to be determined that makes them that gives them an incentive to do the right things. And then I think, beyond that, programs or like the Future Vertical Lift programs, they exist within a community. So there is a program executive office of PEO Aviation that has other programs in there. I believe that really the model-based approach needs to be started at the very top of that and pushed down, and competencies need to be sort of mandated or initiated at that level, and then those people need to get injected into programs, and that is an easy way or an easier way than to try to home grow within each program, which then potentially leads to not consistent application of the models and the modeling tools.
I suppose there's an element of trust as well, right? When you're working as an acquirer, working with folks who are building these models, to understand, if you can't be completely fluent in the models themselves, to trust that you're being shown the right things, right? I was talking with Jerome the other day about I have some work going on at my house, a lot of work, but there are a lot of documents, right? There are in addition to models, which we do have an actual cardboard model, but there are electrical plans and plumbing plans and things like that. And if you can read them, that's fantastic. And if you can't read them, you have to believe that the people you're talking to about those plans are telling you the things that you need to know in order to kind of understand what's represented. Right.
Yeah, I believe things like conflict of interest enter into that. I do think that program offices can rely on outside agents that are not influenced by the contractor, like an independent design agent, to implement some of these to actually act in their as their representative for that sort of a thing. But I do think that we do. I think we want our programs to be able to be fluent in these areas. I don't think it's something that we want to rely on of course, trust is at the heart of it. We have picked contractors. We believe that they are capable and they're going to deliver what we want. But they make mistakes, and we have independent sets of eyes that can look at it and help them do the right thing. Jerome?
Sorry, I fully agree, which is the reason why just before I mentioned the question of model fluency. Are you reading a model, trusting someone to read a model on your behalf to ensure that the right capability is being delivered? We have to sort out all those questions around model-based. There is a question of the stakeholders, there is a question of the modeling process, there is a question of the modeling methodologies, modeling languages, and model processing. So all of that requires that we take a fresh look at model-based techniques, which is part of the research roadmap that we are building on, to try to untangle all those concerns so that we can take the question of model-based concerns from the perspective, let's say, of a PEO or from an acquisition perspective. Ultimately, when you sit in a PDR, you have to review a couple of engineering artifacts. What does it mean to review a Word document versus reviewing a DOORS requirement database or review a set of models? From the perspective of the acquirer, it should be almost the same. You are reviewing artifacts, but you may be more efficient using one approach or the other. But ultimately, we believe that every approach, as long as it contributes to the efficiency of the program, should be on the table. And we want to bring awareness about the trade-off between using one techniques and the other. And so that's why we'll start reviewing all those questions around model-based in the follow-up projects that will start in FY24.
So I think you're right about trust versus fluency, and fluency is a really good goal. I actually have a degree in architecture, and I can read the electrical plans, and I am at a distinct advantage compared to my husband when it comes to that. So there is no substitute for fluency. I think there's one more question I want to address before we close here. Let's see. There's a resistance to modeling because software developers see it as a step toward auto coding and elimination of their role. How can software developers embrace modeling and ensure that their expertise is providing proper value?
Jerome, want to take a crack?
Oh yes, that's a very good question actually, and I mean, if we take the story of software in general, I mean, in the mid-80s, there was something similar between optimizing compilers for C versus writing assembly. And today we're in a situation where, yes, we can use auto-coding. We can even use ChatGPT or whatever will be the next LLM to write software. But what is our expertise? Is it in writing C code or in expressing a design that can be generated? My belief as someone working for the SCI, but also as a former academic professor, is that the expertise of human is in designing the architecture of software, designing new algorithms, and expressing them in some design, whether it is C, C++, Rust, or UML, or any higher level modeling languages. For me, all those modeling languages are nothing but programming languages. And so you can be efficient, you can keep value because you are efficient at delivering something, not because you clock 10 hours a day doing C code. That's not my perspective on this type of work, but because you are clocking 10 hours on delivering value to your program. And this can be achieved using whatever programming or modeling languages. And I truly believe that resistance to modeling is the same type of resistance we may have seen in the late 90s when people were resistant to having gas lanterns in cities. And when we migrated to electric lamp, for instance, I would not say it's an outdated fight, but we have to fight the right fight, which is deliver confidence and trust in the system we build. And this is coming to a question of what is the right technology to achieve this.
Fred, was there anything you wanted to add there?
I think Jerome did a great job.
Okay, so to wrap us up then, you provided that really nice list of recommendations. Let me just ask how likely you think it is that those recommendations will be implemented, and what are some next steps that we can do?
I think in general we have talked about this, at a high level. I mean, the competency of the staff is the key. So how long it's going to take to get the staff up to speed so that they are fluent is a really important first step, and that this is on the acquirer side. Also, there's still this culture that says that we know how to do things, and we have the best people, and we've done this before. And you can look at all of the prior experience that we have from contractors that have that claim this. I mean, you could look at F-35, you can look at all these prior programs where we had the best people on the job, and they still had months, years of delays, billions of dollars of overruns, and yet we still run into, we have the best people on this and we know how to do it, and we don't want to do the modeling. And that's just, I mean, that's a cultural thing that we have to change, and it's going to take demonstrated use of the models in successful applications to get there. And we won't start that until we start actually learning and doing. So that's
How much confidence do you have on the engineering side, Jerome, that this is a mature approach? And to what degree do you kind of await feedback from the field, if you will?
Well, there's a question of the feedback from the field, and actually it has been demonstrated locally in many domains. For instance, Fred mentioned the CAD domain. I mean, we cannot do any mechanical system without those models today. In safety critical systems, we cannot do any of those systems today without specific models, models for differential equations or synchronous models. Speaking of scale, for instance, so we have to scale to the type of systems we are dealing with when we deal with DoD systems, which is a collection of federation of systems. And it will take time, it will take trust, as you mentioned, but most importantly, it will take some effort to know exactly where to inject those techniques in the existing acquisition policies. And it is what is exciting with these discussions that Fred and I are having those days, and that I will come with a specific way of saying, oh, you can architect your system by putting this, and you press this button, you generate the system, you validate a proof, and whatever. And then he will come back to me and say, yeah, but it's not the way it is currently done in the DoD world, because there is first this step and then this step. So we have to go hand in hand, acquisition and engineering teams, so that we can see how to improve the performance of the project that we want to deal with. It is a reason why it's not apple to apple. It is really apple to apple pie. We want to bake the best apple pie. It means that each of us will have to bring the best ingredients, and we have to combine them together in such a way that we get the recipe we want. And again, and this version of apple pie for me is really dear to my heart, because being French, I'm not doing the apple pie the way you guys in the US are doing it, which means that model-based is something that you will tune or adjust with regards to your domain, to your level of maturity, to your appetence to using model-based techniques. And so every project will have to adjust. And this is the interest of engineering and acquisition policies, which is that we have to bring the right level of freedom so that people can see the benefit of using model-based techniques and be given the freedom they need to be efficient and remove as many roadblocks as possible as we're building those capabilities.
That's exciting. Any last thoughts from you, Fred, about what we can do next?
No, I mean, I think it's block and tackle. I mean, I think it's really just doing what we are doing. I mean, so I'm excited to be working in the group that I'm in, and being able to try to develop the competency and to overcome the cultural issues, and that's I mean, it's one step at a time,
Yeah.
So.
Yeah. Great. Well, thank you both. I enjoyed this conversation, and so thank you for having it with me. Thank you to everybody who joined us online, and I will hand it back to you, Shane.
Fred, Jerome, and Linda, thank you for your great discussion today. We really appreciate you sharing your expertise. And we thank you all for attending today as well. Upon exiting, we ask that you hit the like button below and share the video archive if you found value. Also, you can subscribe to the SEI's YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Lastly, join us for our next live stream, which will be on August 22nd. Our topic will be Insider Threat with Dan Costa. Registration information will be on our website soon and will be emailed out as well. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.